All right, this is going to be the second video for Note 74. You can see all the work we did in the first video. So that was question number 1, 2, and 3, talking about domain, range, and starting to talk about inverses. And then question number 3, we found a bunch of inverses. Remember, you're going to swap x and y, and then resolve the equation for y. And that's what we're going to be doing in question number 4, part A and part B. Now, these are a step up from the one-step equations that we did in problem number 3. All right, so problem number 4, part A, of course, is the same thing that we did last time. We are going to swap x and y. That's my weird and symbol, just so you know. And then once you've done that, solve for y. All right, so step 1 here is we're going to swap x and y. So I can find my x right here. Remember, y is the function notation. If you want to, you are more than welcome to write y right over that or cross it out and write y there. That way you remember, oh, that becomes x. And then 2x in the original becomes 2y when we swap x and y. And we're going to now solve for y. So right now, y is attached to two things. There's a multiply by 2 and an add 3. The add 3 is the first thing that needs to go. So we're going to go ahead and subtract 3 from both sides. So x minus 3 is equal to 2y. And then let's go ahead and divide both sides by 2 to get y completely by itself. So let's see, x minus 3 over 2 is equal to y. And then the last piece is the function reset. So it's talking about the inverse of the original function here was f of x. So let's go ahead and do f inverse of x is equal to x minus 3 all over 2. That is the inverse for part A. All right, I'm going to go ahead and slide on over to part B here. And this is going to be, I'm going to be honest with you guys, this is a huge step up as far as steps go. So I'm going to take my time. I'm going to try and be very clear about what I'm doing. But you might need to like double check with me or ask some questions. Always, please ask. Send me a message. Okay, so step 1. We're going to replace x with y, y with x. Now the difference is with this one, and the reason it's a big step up is, yes, we've got y here. I'm going to replace that with x. But I have 2 x's over here, and both of them get replaced with y. All right, so this is going to be x is equal to 5y plus 2 all over y minus 3. Now, I need to start solving this to get y by itself. And the first thing I'm going to do is I'm going to get rid of our fraction here. So it might be helpful, might be useful to go ahead and put this over 1. And the reason is because I'm going to go ahead and cross multiply here to here. So let's do the easy cross. 1 times 5y plus 2. Folks, multiplying by 1 doesn't change anything, so it's just going to stay 5y plus 2. The other cross is going to be to take x times y minus 3. So if you can do that in your head, awesome. I'm going to go ahead and just write out x times y minus 3 using the parentheses, because this means, this is my little note to self, that I am going to need to distribute. All right, so x times y becomes my xy, and then x times negative 3 minus 3x. All right, so no more fraction, not bad. However, we still have an issue that there are 2 y's. So I have a 5y term on the left side. I have an xy term on the right side. Don't like it. I want both of those terms on the same side. Now, which side? Doesn't matter. It honestly does not. So I will go ahead and, I don't know, subtract xy from both sides. Now, at the exact same time I'm doing this, and this can get a little bit weird, but at the exact same time that I'm moving xy to the left side, I'm going to go ahead and take this plus 2 that does not have a y attached to it. So this plus 2, and I'm going to go ahead and move it to the right side. Those terms are unrelated to each other. All right, so a whole bunch of stuff is going on here. Let's try and organize it out. So 5y minus xy, that I'm just going to write those terms down. Oops, write the y. There we go. Plus 2 minus 2 will cancel, right? Equals xy minus xy, that cancels. And then again, just write down the terms that I've got. Negative 3x and then minus 2. All right, does not look like this line is really any different than this line. However, I'm gonna go ahead and slide this on up, okay? However, the nice part is my y terms are together, all right, on the left side, and the right side no longer has any y terms. All right, this is good because this, as weird as it is actually a good step for us. Both these terms on the left have a y in common, so I'm going to go ahead and factor out that common y term. So I'm going to take out a y from 5y, that leaves just 5. I'm going to take out a single y from xy, that leaves x. And then this equals 3x minus 2. Now, you might be saying, why did I do that? Well, instead of now having two terms that have both y in them and trying to figure out how to solve it, I've taken those two terms, and by factoring out the y, this is only a single y, right? This is now the only y in the entire equation, which is good because that means I can now solve for this. All right, this is y times 5 minus x. So of course, we're going to divide by 5 minus x here and divide by 5. Whoops, there's a minus sign there. All right, 5 minus x there. So 5 minus x over 5 minus x, that's gone. Y is equal to negative 3x minus 2 over 5 minus x. And the last thing I'm going to do here is remind myself what this function was. It was g of x. So g inverse of x is equal to negative 3x minus 2 all over 5 minus x. All right, I told you it was a step up, and yeah, clearly it is. I'm going to go ahead and pinch in, all right, so you guys can see the top to bottom of this problem. And I know how I write. I know I write huge, but there's all the steps, right? So step 1, of course, was to get replace x with y and y with x. I cross multiplied from here to here. I distributed from here to here. This step is where I started moving things. So I went ahead and subtracted xy from both sides. I went ahead and subtracted 2 from both sides. Wrote down what I had left here. This is kind of the weird one, but these two terms on the left side had had a y in common. So I went ahead and factored out that y. What was left behind was 5 minus x. This is y times 5 minus x. So to get rid of that, I went ahead and divided both sides by 5 minus x, and that then becomes the last steps here of either solving for y and then rewriting with the function notation. All right, lots of stuff going on with that for part B. All right, let's finish out this set. There's one final question, which I can actually already see, and if hopefully you guys recognize it. I know question number 5 is further over this way. I'll get to the question in a second. But take a look at this g of x function here that's sitting here. Folks, it's the same function that we just dealt with. All right, which is kind of nice. So when I go to question number 5 part, there is no part here, it's just the question number 5, and I ask you for domain and range. All right, let's talk about the domain and range. So of course I do D for domain, and then eventually I'll do R for range. All right, there we go. So D for domain, we have a fraction, and unfortunately I do not want this denominator to equal 0. So as weird as it is, I'm going to purposely take the denominator, set it equal to 0 to find what my problem value is. And in this case, my problem value is the number 3. If I let x equal 3, right, 3 minus 3 is 0. My denominator is 0. Can't divide, okay, all the things. So normal domain is from negative infinity to infinity. However, I cannot let x equal 3. So that means I'm going to split this domain up into 2 parts. All right, we're going to go negative infinity to 3 and then 3 to infinity. So whatever this value is that makes our denominator 0, that becomes the number you throw out of the domain. How do you show me you are throwing it out of the domain? These parentheses mean you do not exclude. Hold on, let me say all the words in the right order. That parentheses set means you do not include 3 as part of the domain. I was trying to say exclude, and it was coming out all weird. All right, so let's talk about range here. And there is no way for me to look at all of these possibilities for, what input values I have for the domain to figure out what range values I do or don't have. But if I remember from the very beginning, last video, The range of this function is the domain of this inverse. So this is why we found this inverse. Well, partially to practice finding inverses, but also if you're going to find the range, you need to find this inverse. So I'm going to do the same thing for this inverse that I just did in terms of I need to figure out what makes that denominator equal to 0, right? That becomes the problem value for my domain of the inverse, which translates to the range of the function. All right, so my problem value here, if I solve for x, is the number 5. So that becomes the value that I need to throw out of the range. So same thing I did with the first one, I had to throw out 3. Well, now I need to throw out the number 5. So negative infinity to 5, union 5 to infinity. So domain is everything from, let me grab a highlighter here, everything from negative infinity to infinity minus the number 3. And then my range is everything from negative infinity to infinity minus the number 5. All right, I'm sure that was a long enough video, but that does conclude lesson 74. As always, please let me know if you have any questions or concerns, and I'll see you in the next one.